Hi, I'm Matt, and in this video we are going to go over how to convert between numbers in scientific notation and numbers in standard notation. So, before we get into conversions, what exactly is scientific notation? Scientific notation is a tool used to write really large numbers and really small numbers without writing all of the zeros. So, for example, instead of writing 3,500,000,000,000 with those 11 zeros, we could just write 3.5 times 10 to the 12th, which is much easier to work with and do math with. So next, how do we write numbers in scientific notation? There are two pieces to scientific notation. The first piece is our coefficient, and it will always be a number between 0 and 10. It doesn't have to be a whole number, but it has to be between 0 and 10. The second piece is called the base, and it's 10 raised to any power. It doesn't matter if it's positive or negative, as long as it's 10 to any number. So if we look at an example below, we have the coefficient in red, and then the base in blue. Moving forward, we have to talk about if it's going to be a positive or a negative number. So if we have a really small number where we have a decimal and then a lot of zeros, that's going to have a negative exponent, such as that number there would be written as 9 times 10 to the negative 9th. While if we had a really large number, the exponent will be positive. So that number there would be written as 9 times 10 to the 9th. Generally speaking, if we have a decimal and then a lot of zeros, it's going to be negative. And if we have a number followed by a lot of zeros, it's going to be positive. Now, let's actually get into the conversions. So how do we write scientific notation from standard notation? Step 1 will be to move the decimal until there is only one number to the left of it, because then we'll have our coefficient between 0 and 10. Now, the amount of places we moved of that decimal will be our exponent. And if we move the decimal to the left, we're going to have a positive exponent. And if we move the decimal to the right, we're going to have a negative exponent. And the last piece is that the coefficient will be what is left after we move the decimal. And we always have to check significant figures. When we convert, our amount of significant figures should not change. So now let's try some examples with this. So for our first example, we're going to do 5,400 to scientific notation. Now you'll realize that there's no decimal here. If there's no decimal, that means it's all the way at the end of the number. So now that we have a decimal, we could go on with our first step of moving it till there's only one digit to the left of it. Here, that digit's going to be the 5. So we're going to move the decimal 1, 2, 3 places, because then there's only one digit to the left of it. Since we moved it 3 places, that's going to be our exponent on the 10. Now, we just need our coefficient, which will be the 5.4 in this case. Because we need two significant figures, because 5,400 is two significant figures, so we're going to take that 5.4. And that is our number in scientific notation. Generally speaking, we're just going to take the non-zero numbers, but you will see some examples where we might want one of the zeros there as well. We're going to do this question the same way we did the last one, even though it looks a little bit more challenging. We're going to put the decimal all the way at the end and move it till there's only one number to the left of it. Here, that will be the 3. So let's start moving the decimal. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Since we moved it 10 times, our exponent's going to be 10. Now, since we moved it to the left, that would be a positive 10. If we moved it to the right, it would be negative. Now, once again, we need our coefficient. which here is the 3.62, because we need 3 significant figures in our coefficient. So even though this looked much harder, it's all the same steps. Let's try one where the exponent will be negative. So here, as I said previously, we're going to have a negative exponent because this number is small rather than very large. So we're still going to do the same steps. We're going to move the decimal until there's only one number to the left of it. So here, that's going to be 1, 2, 3 times. And the new location of the decimal will be here. Now, once again, since we move the decimal to the right, this is going to be 10 to the negative third. And now, what our coefficient isn't going to be the 6.9, but the 6.90, because this number as a whole has 3 significant figures, so our coefficient must have 3 significant figures. And our solution here will be 6.90 times 10 to the negative third. For our last example, we are going to work with this really small number. So, since it's a small number, we're going to be moving the decimal to the right, and we're going to have a negative exponent. So now, like we did previously, we're going to move the decimal till there's only one number to the left of it. So that would be 3, 4, 5, 6, 7, 8 times, and the decimal will end up there. Since it will be negative, our base and our exponent will be 10 to the negative 8th. And now the last thing we need is our coefficient, which will be the 3.64, because this number had 3 significant figures, so our coefficient must also have 3 significant figures. Now that we've talked about going from scientific notation to standard notation, it's important that we could go back the other way and get standard notation from scientific notation. So really, we're just going to do everything backwards. If the exponent is positive, we're going to move the decimal that many places to the right. So if the exponent is 5, we're going to move the decimal 5 places to the right. If the decimal is negative, we're going to move that decimal that many places to the left. And then, once again, we're going to have to check that we conserve the amount of sig figs. Let's try some examples doing this. The first thing I like to do when I convert from scientific notation to standard notation is rewrite the number. So we have 3.67. And then we're multiplying by 10 to the 5th. Since it's a positive exponent, we're going to move the decimal that many places to the right. So here we're going to move it 1, 2, 3, 4, 5. And then we're going to fill in all those gaps with zeros. So here we would end up with 367,000. Now, you would see that the decimal is after those zeros, but if we put a decimal there, that would make this 6 significant figures, while the 3.67 is only 3. So we're going to leave this as our final answer and leave the decimal point as absent. For our next example, we're going to look at 7.9 times 10 to the 11th. We're going to start the same way as the last example, writing 7.9. And then, since we have a positive 11, we're going to move the decimal 11 places to the right. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then fill each of those spaces with a 0. The hardest part with these types of questions is making sure you don't add or subtract a 0 that should be there. And once again, we're not going to put that decimal because that will make it too many significant figures. We just want the 7 and 9 to be significant. So we will just write 7, 9, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 zeros in this case. And this is your final answer. For our third example, we're going to try 1.20 times 10 to the negative third. Since it's negative, we're going to move the decimal place to the left instead of right. So here we're going to move it 1, 2, 3 places to the left. And that will give us 0.00120. And we're going to leave that 0 there because we need our answer to be 3 significant figures, because 1.20 is 3 significant figures. So it is important that we leave that 0 there. For our last example, we're going to try 4.87 times 10 to the negative 9th. Once again, we have a negative exponent, so we're going to move our decimal to the left. And in this case, we're going to move it 9 times. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And then fill in all the gaps with zeros. And that's all we have to do here, because there's no zeros in our coefficient, so our answer will automatically have the correct amount of sig figs, assuming we don't add any lines or any notation. So here will be our final answer. Now that we've done some together, here are 6 practice questions you could try on your own. For the first 3, convert the following numbers in standard notation to scientific notation. And for the last 3, convert those numbers into standard notation. The solutions will be provided for you on the next slide. The solutions are as follows. 1a was 3.35 times 10 to the 5th. 1b was 1.6 times 10 to the 8th. And c was 3.20 times 10 to the negative 10th. Question 2a was 200,000. Question 2b was 0.00312. And question 2c was 0.11 zeros, then 817. Hopefully you got these. If not, feel free to leave any questions you have in the comments below. Thank you so much for watching. Have a great day.